Hello, this is Maths with Lemon, and in this topic we will see motion in a vertical plane. Now, first of all, if the paper and the dart are dropped in a vacuum, then they fall at the same time. So basically what we say, when there is a vacuum, inside the vacuum, two objects with different weight, they fall with the same rate. When we will do calculations in this lesson, we will make the following assumption. The air resistance is small enough to be ignored, and the acceleration due to the gravity is the same for every object regardless of its weight. So basically unless otherwise stated in the question, the acceleration will be always 9.8 meters per second square. There may be some cases where they will say, oh, the acceleration is 10, but that's the procedure will be the same. Now, using the standard model, the acceleration due to the gravity is a constant. This means that we can use the constant acceleration formula to work out how a falling object behaves. So let's have this problem. A stone is dropped from a cliff and lands in the sea 4 seconds later. How high is the cliff? Now, for this kind of problems, they will give me the equations of the kinematics formula. Let's start by drawing a simple labeled diagram indicating the direction taken to be positive. So I'm taking as a positive direction downwards. Here is the cliff, so we drop the stone from here. Now, relate the information to SUVAT as usual, which means what? S is the distance, and in this case it's h, the height. U is the initial velocity, which is 0. When I leave the stone from here, it doesn't have any speed. The initial speed is 0. The velocity, A, is the acceleration due to gravity, and T is 4 because it says that it needs 4 seconds. So basically, which formula I will use? I will use the distance formula. It will be given again, I'm saying. So basically, S is the initial speed times T plus 1 over 2 A times T squared. If I'll substitute, then the answer will be 78.4 meters. Now, projecting an object downwards is much like dropping it. It's like dropping it, more or less, except that its initial velocity isn't 0. So a stone is thrown downwards with a speed of 4 meters per second. Now you have to understand that I have an initial speed, 4 meters per second, and hits the ground with a speed of 18 meters per second. Calculate the height. Now, again, I throw my stone from here with this initial speed. The positive direction is downwards, and when just before hitting the ground, the stone has this speed. Now again, how much is my S? I don't know. What's my initial speed? 4. My velocity 18, and the gravitational acceleration 9.8. Now in this case, I will use this formula where it involves the final speed, the initial speed, the height, and the gravitational acceleration. Again, these formulas will be given. I substitute, and then I solve in terms of h, which is 15.714. So the height is this one. The last case is when an object is projected upwards. Then it is easier to choose upwards as a positive direction. don't forget, in the previous cases we always were choosing which is going to be the positive direction. Now, because the stone was falling down, I chose the positive direction to be downwards. Here in this case, I project the stone upwards. Now, the acceleration due to gravity is then given a negative sign, because don't forget, the acceleration is always downwards, because the gravity pulls the object downwards. So since I have a positive direction upwards, the gravitation should be negative. Let's see that. An apple is thrown vertically upwards with speed, so I have an initial speed, 8 meters per second, from a height of 1.6 meters above the ground. Find the greatest height reached by the apple. Let's see. So I am here, I'm throwing the apple upwards, I'm taking as a positive direction upwards. The initial speed is 8 meters per second upwards. The gravitational acceleration, it will be downwards negative. So let's see, relate the information again. Now, at the maximum height, when the apple will go upwards, at some point here, when it will reach the maximum height, it will stop. So the final velocity will be 0. And now I will choose this formula again, where I have the height, the gravitational, the initial speed, the end velocity, the final speed, and as the height. So I will substitute, and then I will find that the height is 3 meters upwards. At the projection, I have also 1.6 meters, so basically totally the height is that. Now, the displacement when it hits the ground is negative, as it is 1.6 meters below the start. If you see that here, in my case here, the displacement when it will hit the ground is negative, as it is 1.6 meters below the starting point when I throw it. Now, which formula I will choose for my second question? S equals initial speed times plus 1/2 t squared. If I'll solve it, I will find that t has 2 times. The negative is being cancelled, so basically it's 1.8 seconds.